Let's go.
Hi, I'm David, and today I'm here with Gerard.
Hello.
To talk about adaptive layouts and why using them can cause you a few headaches. First, let's consider this pretty standard and common screen that the Android developers face regularly. You have a top-up bar, a bottom navigation bar, a primary action button, and probably some content. And then one day, your team decides to make the screen compatible for all the different form factors, and you will probably end up with something like this. Now, if we consider that the content of the list is clickable, and that a click on an item will display a detail screen, you will end up with having two different screens on a phone, two screens side by side on foldables, two screens side by side, and probably even more on tablets. You will probably also have to move the bottom navigation bar to the side and use a navigation rail when it makes more sense based on the device configuration.
Before talking about what is the issue to be compatible with multi-form factor, who here already tried to be compatible with this kind of device here? Okay, okay, cool. If you already try, probably the issue I will describe, you find them, because there are some issue with this kind of device. Here we have a potential structure, gradual module architecture in an application compatible with mobile phone. So you have the entry point, you probably know, of course. This is the app main module. We have here a main navigation gradual module to handle the navigation between all screens in your application. And we have some feature module, here feature 1 screen VM and feature 2 screen VM, which are not view model, but Jetpack Compose components linked to a view model, and with the responsibility to populate Jetpack Compose screen, which are feature 1 screen and feature 2 screen. And so these two screens, feature 1 screen and feature 2 screen, create their screen with some molecule and organism components you can find just below. Okay, so if we want to be compatible with, for example, the tablet device, what we can do? The first potential solution is to create a feature tablet screen that will display side by side feature 1 screen VM and feature 2 screen VM. But the impact of this component is to create a new route at the navigation level to be able to go to this component screen. That will increase a lot your navigation graph, because you need to take care about, at the runtime, on which device configuration your user are. So for example, if we are on the tablet, we need to use the tablet navigation, and if you are on mobile phone, we need to use the mobile one. So, of course, it is not a very good solution. Another solution is to have a magic layout, here navigation layout, to handle for you the complexity of the navigation. So, we suppose that this hypothetical layout, for now, will handle for you only one route for every screen you will have in your application, no matter about if there are more use on tablets or mobile device. Another issue with this kind of architecture is to put all navigation components before at the screen level, but now at the navigation layout. For example, the bottom bar navigation is probably more declared in the feature module level, because you will have at this level the scaffold components. But because we need to take care about the navigation at the navigation layout level, we need to take these components and put them at this level. What it means that if you want to have a bottom navigation in some screen and not on other screen, or if you want a floating action button, because floating action button is also a navigation component, and you want to display a floating action button for one screen and not necessarily for another screen, or different floating action button, you need to notify your navigation layout that any change you can have at the screen level, like a screen change.
So Jean introduced us to the different issues, but to start tackling them, what tools do we have at our disposal? The first set of tools are the component levels, and there are 3 of them. So we have this reference screen, and if you want to build the screen, based on the atomic design principles, you will need molecules. If you take a molecule, you put that, for example, in a list, you will end up with an organism. And if you take the molecules and the organism, that's the UI component level. Now, if you take the different UI components that you previously built, and you put them in a container, that's the screen component level. You have to know here that we chose to put the navigation bars inside the screen component. It's just because it's simpler for the explanation. And just keep this detail in mind, because we will come back to it later in this talk, and it's going to be interesting. And lastly, we have the highest component level, the app component level. And it's basically just a container component, which main role is to navigate the user between the different screens of the app. Another tool that we have access to are the infamous adaptive layouts. And first, let's see on what tools they are built on. The first one is the window inset, and basically it allows us to measure the characteristics of 2 things, the OS status bar and the OS bottom navigation bar. And mainly the goal here is to have those characteristics to be able to draw our app behind them. Next we have the window manager, which handles all the data about the device configuration. And it also allows you to measure some hardware characteristics, like the screen height and the screen width in pixels. Those 2 APIs are pretty low levels APIs. Now we have the window size classes. It's a set of opinionated viewport breakpoints that you can use to design, develop, or test your responsive application layouts against. And the window size classes are available for both the height and the width. You note here that the breakpoints names are compact, medium, and expanded. The interesting point is that they are not named, for example, phone or tablet. And it's because we don't deal with the old phone versus tablet paradigm anymore. And now the new approach is all about using the available screen space. And why is that? It's because your user can use 2 apps in split screen mode. It's kind of easier to visualize on tablets where you can have let's say a chat application matching the compact width on the left side of your tablet, and then the rest of the tablet is used to focus on whatever app you want to use. Now we have the 2-pane layout, and it's a tool that lets you declare and display 2 screens with a single layout. It's provided by Google, and it's a very opinionated approach that allows you to configure a bunch of parameters, like the distance between the 2 subscreens. It can also handle like any physical separations you could have between your 2 screens. And it lets you configure the width of each subscreens if you want to display a least detailed layout, for example. So you have the window inset, the window manager, the window size classes, the 2-pane layout. All of them, again, are a set of pretty low-level APIs, which means that the user experience as a developer is not quite there. So that's why Google has built a set of 3 higher-level solutions. The first 2, the list details and the supporting scaffolds, there are two ready-to-use solutions to handle the list detail layout and a layout that has a supporting pane. And for those of you who don't know what a supporting pane is, it's basically a screen which goal is to assist the user in his experience of the main content by bringing additional value. Those two new scaffolds are built on top of the set of tools that I presented previously. And the last one, you have the navigation suite scaffold. So at the beginning of the talk, I said that we have to move the navigation bar to the side using a navigation rail, for example, based on the device configuration and when it makes sense. And the navigation suite scaffold is a component that does exactly that by relying on the window manager and different other tools. All we have to do is to provide the content that we want to put on screen and the different items that we will need for the navigation bars. For example, the bottom navigation bars, the nav rail, the navigation drawer. And boom, everything will be handled for us with this component. So the list detail, the supporting, and the navigation suite scaffold, they are all brand new components that are available right now, but they are currently available in very early alpha.
And very early alpha is very, very early alpha. For information, we give this talk 3-4 times now. And for every repetition we do, we need to update our slide with new contract API. So yeah, probably you will see, don't use it right now, but it's interesting to have this in mind that Google work on it very hard to provide some new scaffold in the future. But okay, we know the theory now. We need to, but we probably want to make some tests on a real-life application. So this real-life application is this application, a conference app, which is in production for one conference in France called DFS Lille. Developed by a very big team like me, and it's all. But it's okay. The idea is to have an application that have some screen and some complexity inside, and some big domain feature to integrate all these new scaffolds. So this application have some main feature. First one, of course, the list of schedules. We have also the list of speakers, a space to make some networking, the list of partners, and some details about the events. And of course, we can open some item inside, like the talk item to display the detail of the talk, the speaker item to display the detail of the speaker, and of course, the partner item to display information about the partner. Pretty simple and pretty classic conference application. And so first, we will need to rework our component architecture to prepare the compatibility with multi-form factor devices. So come back to the Gradle module architecture, but contextualize about our application. So we still have the app module for the entry point of the application. We still have the main Gradle module for the navigation. And we have some feature module which correspond to the big domain feature in the application, so the schedule, the speakers, partners, etc. And inside this kind of Gradle module, we have some sub-modules. The first one feature will contain all view model and Jetpack Compose components which are linked to this view model. We have UI Gradle module to contain all screen and UI component levels. And last one, DI for the dependency injection, not interesting for this talk. And we have finally core modules for the business logic, so everything inside shared and shared DI. Models for the models between the backend and the front ends, not interesting for this talk too. But more interesting, we have the style one to contain the theme of the application and some atomic elements like text, buttons, icons, colors, etc., etc. Okay. So come back to the application, and so you can find here some screens inside this application. So we have 2 screens from the schedule Gradle module and 2 other from the speaker one. And you can probably see that we have some common components inside. We have first the talk item, which is used in the list of schedule, and inside also the speaker detail. And we have the exact same thing for the speaker item, which is displaying the detail of the talk and the list of speakers. And what is the issue with that? If we come back to our Gradle module, we have inside the UI Gradle module all screen and UI components. It means that to display the talk item inside the speaker details, which are both inside the UI Gradle module in schedule and in speakers, I need to make a dependency, and for the exact same thing in the speaker screen, I need to make a dependency between the UI Gradle module of schedule to the speaker one. Of course, I got cyclic dependency, Gradle dependency, and I cannot do that. So a pretty simple solution is just to create another step inside this Gradle module, and so I create a new one called screen for all screen component level. Okay, but another issue with that is when I create the talk item components. First, it was dedicated for the list of schedule. And later, I got the idea to put the talk of the speaker in the speaker details. And so to do that, I just take the component from the list of schedule and put it inside the speaker detail. It works sometimes if your Gradle module architecture is okay for that. But there are some more interesting approach to do this kind of thing. Another approach is to create a dedicated location for your UI components here inside the style one. Probably not anymore linked to your screen, but linked to a design specification, probably described inside a Figma project, to specify all components in your application and all variants of your components that can be used for different device configuration.
So the approach that we adopted and we advise you to use is to start working on the landscape mode of your application. The first thing we had to do was to deal with the size variance to handle the height topic. So let's take this component inside the app in Portrait. In the landscape version, we have less vertical screen space, and the best solution is to use a component that is more compact vertically wise. First thing we did, built a small variant of this component, and it looks like this. Then the next thing we did a medium variant of that component, but it totally could have been a large variant. And it looks like this. So when we do a comparison side by side, you can pretty much tell which one we use for which orientation. And for your information, despite the height difference, they provide exactly the same level of information. Then we had to adapt the UI based on the window configuration to deal with the width this time. So in Portrait, we have this schedule screen and a second filter screen that will be displayed when the filters icon is clicked. So in landscape, the window with size class will tell us to display both screens side by side. And thus, we don't need the filters icon anymore in this orientation. So we started by building the filter screen. Kind of a classic screen looks like this. Then we built the schedule screen. And the thing that we have to note here is that we had to use a visibility boolean to show or hide the filters icon. A naive way of getting the result that we wanted to get was to implement stuff this way. So the first thing we did was detecting the screen orientation. So if we are in landscape mode, we add our schedule screen component. And note here that we had to hide the filter icon by setting the Boolean to false, and we also had to declare an empty callback for the filters icon that we won't even display. Then we added our filter screen component. And by putting them both in a row, we are able to display them side by side. If in portrait, we only have to display our schedule screen component. And this time, note that we will display the filters icon, and a click on it will actually do something.
If you already try to be compatible with, no, sorry, who already try to be compatible with landscape mob in their application here? Okay, not a lot, and no one in the balcony. Great. It is very important to be compatible with the landscape mob, and why? Because yes, in the mobile configuration, users use probably more in portrait mode than in landscape mode. But if you start to work on multi-form factor device, the foldable device and the tablet device is more used in landscape mode. So if you want to start to work on your multi-form factor compatibility, it's a good start to work on the landscape mode for your mobile application, because you will need to remove your restriction in portrait mode for your application when you will start to work on other kind of device. So please take care about your landscape mode. And for information, it is very interesting to create some layout for this kind of orientation. But okay, the first implementation that David previously presented you is a little bit naive and don't use the capability of adaptive layout. Let's see how we can migrate this implementation with adaptive layout. First, we will focus on the navigation suite scaffold. So for a reminder, the navigation suite scaffold allows you to specify the correct navigation bar for any kind of device. So like you can see on the compact mode, navigation suite scaffold used the bottom bar navigation, but for other kind of device, we have the navigation rail, and if you want, the navigation drawer. The contract is pretty simple. Here you have the contract of the navigation suite scaffold, and there are two interesting parameters. The first one is the navigation suite items, which allow you to declare all items you want in the navigation bar, with a pretty similar contract that you can see in the navigation rail and the bottom bar navigation. And we have the layout type with a very complex default value, but behind this call calculates from adaptive info. It computes the window size class in width and height to get to know what is the best navigation bar to use for your application. But because it is a parameter, we can override this behavior. For example, if I come back here, you can see on the mobile version in landscape mode, we are using a navigation rail. But the default implementation is a bottom bar navigation. I don't know if you already tried to use an application in landscape mode with a bottom bar navigation and a top bar navigation, sometimes with some tabs. You don't have a lot of space to scroll in the contents. So we decide to override this behavior to use a navigation rail, and because it is a parameter in the contract of the navigation suite scaffold, we can. The usage is pretty simple. We are here in the app navigation, at the navigation level in our Godel model architecture. And as you can see, we call the navigation suite scaffold, and we have first the navigation suite items parameter, where we declare all items we want in the navigation bar. So we iterate on a nav action list, and so inside we call the function item with inside some parameter like if it is selected or not, the icon, the callback to notify when the user click on it. We can also have some customization, color customization if you want, and the label if you want to have a label inside your application. And in the contents, we have the nav host to declare all screen of your application. Next one, canonical layouts. For people who don't know what is canonical layout, it is what we talked just before, the supporting pane scaffold and the list detail scaffold. We have some other one, but not with a technical implementation for now, like the feed one, which is more used in like actuality application, and probably more in the future. But today we only have two technical implementation, list detail and supporting pane. And so we want to use the supporting pane on the list detail screen, with the list detail has the main pane of the screen, and the filter screen has the supporting pane. And the list detail, we want to display the list of speaker at the left and the detail of the speaker at the right. Great. So let's start with the supporting pane scaffold, and we have some interesting parameters here. First, we have API slot for the main pane and the supporting pane, so to declare the list schedule screen and the filter screen in our case. We have also the extra pane for temporary screen, like a bottom sheet or a modal, if you want. After that, we have the directive, which is about, it is a new one.
It's the layout.
Yes, it's about the spacing of the layout, so spacing around your pane, so around your pane, between two pane, and around the margin of all your pane you can have in your screen. And the value one is if you want to override the window size class of a specific pane. So, for example, you can say the supporting pane of my supporting pane scaffold is not a compact one, but a medium one. And so you can override this if you want. Okay, the usage is pretty simple too. We have here the schedule grid adaptive at the feature module, at the feature gradle module. So we are at the screen level here. And so we have first the navigator, which is the state of the scaffold. And we are using this navigator to declare, to initialize the directive and the value. So if you want to customize these two parameters, you need to customize them inside the call of the remember, etc. Call just before. And after that, we declare the screen for the main pane and the screen for the supporting pane, and it's all. So pretty simple. The second one is a little bit more complex because we want to have some interaction. Because when I click on an item in the list, I want to open something. I want to open a screen if I am on a mobile device, and I want to open the pane at the right if I am on tablet or foldable device. So I have the pretty same parameter, but adapted for the list detail pane scaffold. So list pane and detail pane for the list at the pane. The extra is the exact same parameter, and same for the directive and the value one. Okay, the usage here we are at the in the speaker adaptive components at the feature gradle module level, and so we have the navigator. So the state of this specific scaffold. We have also an internal state to save the current item selected by the user. So we need to take care of this by ourselves. It is not handled by the scaffold. We initialize this parameter in the directive and value parameter, and after that we can declare our screens. So here we have the list pane parameter with the speaker list screen call, and inside we have the callback to notify when the user click on an item. And so you can see that we save the selected item, and we call the navigator, we call the function navigate to with the navigator variable to notify the scaffold that we want to open this detail. So the navigation is no more just only handled by navigation compose or something else. The less detailed pane scaffold handle navigation too. So you need to accept this in your application. But okay, I accept it. So I have this for the list pane, and the detail pane is a little bit more complex. But first, I have the declaration of my detail screen only if my selected item is initialized. I have also an animated pane to have an animation to have this feeling that I open something. So I have the animation of the screen that comes from the right to the left to have this feeling that I have something open it. And finally, because on mobile device I want to display a back button in the top up bar, I want to check if it is initialized or not. So I have a first check about the visibility boolean about this icon first, and if it is yes, so if I have this icon on my screen, I declare my back icon button, and inside the callback of this component, I'm checking the navigator if I can come back. So if I am on a mobile device because I open the screen, and if I can, I go back.
Okay, so we took the tools that we have at our disposal. We use them to build a real-life application. Now let's talk about a few issues that we encountered during our journey. One of the most important friction points we encountered was there are some conflicts in the material design specifications. We are going back to our reference screens. Just a quick reminder. That the material design specifications indicates that the top-up bar and the bottom nav bar should be displayed edge to edge, and there have to be some padding around the main action button. Now, if we go to the material design specifications, but for multi-form factors, and we focus on the compact breakpoint, you have something like this. Just to simplify things, we will remove the status bar. Now we have this, and we want to implement our reference screen. So we will end up with something like this. And you have to notice that now we have some paddings at the top and at the bottom. But we also have some paddings on the sides of the screen. And the right padding will also add up to the padding that we are supposed to have around our main action button. Things have changed since we started writing this talk. We have this pull request that got submitted a few weeks ago, and it says, after deeper investigation and discussion with designers, Google decided to remove these paddings. So cool things, the software engineers and the designers are starting to talk things out. So that's cool.
Who think that it is easy to use a floating action button here? Okay, not a lot, pretty surprising, but because me too. For me, the responsibility of the floating action button is not clear to know when we should use this component, and that is the same feeling for Google engineer and Google designers too. But what is the issue of the floating action button with adaptive layouts? We come back to the Guadal module architecture, and previously you declare your floating action button at the screen level, because at the screen level you have your scaffold where you can put inside the bottom bar navigation, the top bar navigation, the contents, some interaction also, like when you scroll in the content you want to hide the top bar, the bottom bar navigation. But with the adaptive layout you need to put all your navigation components at the app level. That means that you cannot do this kind of thing anymore because they are not inside the scaffold component. Another issue with the floating action button is this. Here we are in the navigation, in the networking space, and we have two tabs inside the screen. We have the profile and the list of users scanned at the events. And in these two screens, in the first version of my application, I have a floating action button in the profile to edit my information, and I have a floating action button to enter in the scan mode of my application. And if I want to work on the landscape mode or on the foldable/tablet mode, I need to develop this kind of thing. For information, the navigation URL, the design specification of the navigation URL says that you need to dock your main, your floating action button inside the navigation URL. It is not yet possible because the navigation suite scaffold is not compatible yet with this kind of thing, but it is described in the design specification of material design tree. And to do this, I need to choose only one main action for these two screens because I can display these two screens side by side in landscape mode. The response of Google to handle this kind of thing is just to rethink your user experience and clarify what is your real main action of your screen. And so here we decided to remove the floating action button in the profile to add the button in the screen. But it is, for me, a workaround. We should not be impacted by adaptive layout stuff. We should not impact our UI we want in our application because there are some restrictions in adaptive layout. But it's my point of view.
So another friction point, the window size classes are not available for subcomponents. If we take this base screen and we apply the different tools we talked about, we will end up with this screen. And the UX on this screen is pretty okay. But what if we want to provide an enhanced experience for these screens? And if this is the case, we might want to provide components that are optimized for this specific configuration. Now, let's say that we want to display more speaker cards on a single line. For example, on tablets, they are just going to get bigger. And what we want is for them to keep their size, and we want to display more of them on a single line. And to do that, we need to know the window size class that we want to apply on a subscreen. And for the moment, we won't be able to do that because the window size screen breakpoints only are available for the whole screen and are not available for a specific part of the screens. So it's not impossible to do that, but you will have to do that yourself. And that's some extra work that we think can be skippable if we had the proper tools to do that.
Box with constraint is your best friend for this kind of thing. But okay, so what is the conclusion of this talk? Who wants to try this new scaffold in their application tomorrow here? Okay, cool. I don't know why, but okay, cool. If you check the official Android developer website, you can see this kind of page about large screen and some inspiration of what you can do with large screens. As if Google provide me some new scaffold to be able to do this kind of thing, yes, me too. I want to be compatible with this new device. But today it is too much restrictive and maybe not very stable for now to to adopt this the new adaptive layout in my professional application. But there are two interesting things we can start to work to be compatible in the future with adaptive layouts. Is first start to rework your component architecture to have your components with someone in the app level, one specified in the screen level, and someone in the UI component level. So we work all your components to specify all these kind of components. And the second thing is to start to work your landscape mode for your mobile application, because you will need to remove your restriction in portrait mode, and starting now to be compatible with the landscape mode will prepare you and your architecture of your application to be compatible later for foldable and tablet device. Some reference if you want to check some what we present you today. There are a lot of things described on Material Design 3 websites. So you have 3 links about everything we present you today on the design parts. There are also the large screen gallery if you want to have some inspiration and to give it to your designer team. Take care about that, because when you share this kind of thing with your designer tomorrow, they want to do it in your application. So yeah, be sure to share this kind of thing. You have also the Now in Android application start to integrate these new scaffolds, but the Now in Android application is pretty simple. So maybe if you want some real life use case, you can check the last link, which is the source code we present you today in this talk. So it is completely open source, so you can check and try by yourself if you want. Thank you. Some time for question?